Hey everyone, this is Doc Almighty with another tutorial on Immersive Engineering. In this video, I'll be covering everything you need to know about power transmission and storage. First, I'll briefly show you the blocks and recipes I'll be using in this video. The first thing that you should do in Immersive Engineering is craft the engineer's manual. It's simply a lever and a book. And when you craft that, you'll have an instruction manual about everything related to immersive engineering. It's an invaluable tool, and as far as manuals go for mods, it's pretty doggone good. I'm going to run through all the recipes for the basic blocks really quickly. I don't like to spend a lot of time on this because I think we all have the NEI mod. That will show you the recipes. We don't really need to go over those in detail, but briefly, a basic block is the engineer's hammer. This is useful for many things in immersive engineering and something that you will need to craft. That's just 2 sticks, 2 iron ingots, and a piece of string. Additionally, we'll use the wire cutters. This makes it easy to cut power lines without having to break connectors and whatnot. This isn't a required tool, but it does make things easier. And that's crafted with 2 treated sticks and an iron ingot. The treated sticks require creosote, which requires another multi-block construct in covered later in the tutorial series. The next tool is the voltmeter. Now this thing's of questionable utility. I'll show you in a little while, but it tells you how much power is stored in a capacitor and whatnot, which is also shown in Wayla, and it's much more convenient looking at it in Wayla. But what the voltmeter does do is when you shift right click on 2 different power points, it'll tell you the energy loss between them, and we'll cover that in great detail because it's important. But it's crafted with 2 treated sticks, a copper ingot, and a compass. And last but not least, we have the engineer's toolbox, which is constructed of 3 aluminum plates, a wooden storage crate, and 2 rose red. Any kind of red dye will work in this recipe, but that'll give you an engineer's toolbox. And what the engineer's toolbox does, it's a handy little toolbox where you can store all of your wires and tools, etc. It's just a matter of convenience. All right, so that's all the tools. Now, to transmit power in immersive engineering, we don't use the kind of pipe-like power constructs that you see in some of the other mods. They actually have power wires, which makes it look a lot more real world. And there are 3 different tiers of power wires. Low voltage, which I'm showing here. Low voltage wires transmit up to 2048 RF per tick, and that's simply 4 copper ingots around a wooden stick. And you can see that crafts you 4 low voltage wire coils. Similarly, the medium voltage wire coil transmits up to 8,192 RF per tick, and that's simply 4 electrum ingots around a stick. That also gives you 4 medium voltage wire coils. And last but not least, the high voltage wire coil transmits up to 32,678 RF per tick, and this is constructed using 2 steel ingots, 2 aluminum ingots, and a wood stick. Note that I said aluminum, and I'm an American. In immersive engineering, it actually is aluminum and not aluminum. That being said, you can substitute aluminum ingots from other mods in the recipe and it will still work. But if you're looking for the immersive engineering brand of aluminum, you won't find it under aluminum. It is actually aluminum. All right, enough of that. Now, the next couple of blocks that we need to go over before I show you how to wire these up are the wire connectors. Unlike other mods, you can't just take these wires and hook them straight up to machines or power generating blocks. You have to use these connectors to, you put the connectors on your power generation and power consumption blocks, and then you wire up the wires between the connectors. So the connectors actually act as kind of a bottleneck for the power. For the low voltage wire connector shown here, it can only input 256 RF per tick. And that's constructed using 4 hardened clay and 3 copper ingots. That gets you 8 low voltage wire connectors. For the medium voltage tier, the max input is 1024 RF per tick, and it's constructed using 4 hardened clay and 3 iron ingots, giving you 8 medium voltage wire connectors. And of course, we have the high voltage wire connectors, which are 3 aluminum ingots and 6 hardened clay, and that gives you only 4 high voltage wire connectors. So they're a little bit more expensive. There's also a little bit of a different construct. The low voltage and medium voltage connectors have different behavior than the high voltage. For example, on the low and medium voltage, you can hook up any number of wires to these connectors, but on a high voltage connector, you can only attach 1 wire to these. To actually transmit power, we use a high voltage wire relay instead, and I'll make that a lot clearer when I show you how to wire these things up. But for those of you curious, we have 3 iron ingots and 4 insulating glass blocks, and those insulating glass blocks are constructed with cactus green, glass, and iron grit. This iron grit is similar to pulverized iron or iron powder or iron dust. Same construct as in many other mods. This one is, these grit items are constructed using a crusher in Immersive Engineering, which we'll cover in a later tutorial. All right, so let's get to the good stuff. So I've got a wall here, and I'm going to take this opportunity when we're wiring these up to also show you these wall mounts. There are 2 varieties, wooden wall mount and a steel wall mount. They don't really differ much except for the aesthetics, but I'm going to show you how to position those real quickly. If you take a steel wall mount, if you want it oriented up where the connector is on top, all you have to do is point your cursor at the top half of the block you're putting it on, and it will be oriented up. If you want to orient it down, you point at the bottom half of the block and it'll be oriented down. All right, so let me grab some wire here. Whoops. And let's wire some of this stuff up. Now, to put wire on these connectors, all you have to do, I've got a low voltage wire connector. I am using low voltage wire coils. Right click here, right click on the next connector, and it strings them together. It's really that simple. Same goes for medium voltage and for high voltage. Now I've got one connector here and a relay here. You can see so it works the same way. All right, so we've got the connectors and the wall mounts. Now I'm going to cover capacitors because I have these all over the place. Capacitors are the power storage construct. It's for Immersive Engineering. There are 3 tiers. They're not terribly complicated. For the low voltage tier, it's simply 3 iron ingots, 2 copper ingots, a lead ingot, 2 treated wood planks, and a piece of redstone. Likewise, for the medium voltage, same recipe, except you have a redstone block instead of a piece of redstone, and electrum ingots instead of copper ingots. The high voltage capacitor, the recipe is a little bit different. 3 steel, 2 aluminum ingots, a block of lead, a block of redstone, 2 treated wood planks. All right, so let's look at capacitors and see how these work. Now I need my trusty hammer, which is here. I'm also going to need this other stuff. All right, so with our hammer, if you notice, to configure inputs and outputs on the capacitor, there's no GUI involved here. It's simply tapping it with a hammer. So you can see on the top, we've got a blue dot here. That signifies that's an input side. All you have to do is right click with the hammer and it'll give you an orange dot which indicates output, power output. You can click it again to have no configuration at all on that side, but we'll leave that as input. Now likewise, you can also hit shift when you click and it'll configure the opposite side. So for example, if you had this capacitor butted up against a machine that was it was powering, you don't want to have to break the block of the machine in order to configure the side. You can just come to the other side, hold shift click, and then you'll see on the other side it's now an input. If I go back and shift click again, now it's an output. So that's all there is to configuring a capacitor. So we have the three tiers. This is a low voltage capacitor, and right now I'm stringing these through a current transformer. We'll cover this really quickly. A current transformer is pretty useful in that it helps you measure the amount of power going through a particular or through the wires that are hooked up to it. This is used frequently when you're setting up things like water wheels to make sure that the water wheel is outputting the maximum amount of power. You can't really see that visually, so it's really handy to use this current transformer to measure that power. So if I hook this current transformer up to the capacitor that has power, if you see over here, this capacitor is not yet full. There's no power passing through right now. But once I wire this up, what did I just do? Once I wire that up, now the power is transmitting. And if I right click, you can see that's starting to go down to 0 because the power filled up. But at 254 RF per tick was what went through there. Now you might wonder if this connector is supposed to transmit 256 RF per tick, why did we only have 254 RF per tick going through there? That's because there is energy loss in these wires. The longer distance they travel, the more energy that you lose. So for example, if I do the voltmeter and I shift, you can see that it tells you how much energy is stored in there just by looking. But if you shift right click on it, and that's your original point. If you then go to the next point and shift right click, it tells you the average loss between those points is 1.25%. Now the longer the wire goes, the more energy loss that you'll have. So that's something to keep in mind. Now you can see that I've got a medium voltage capacitor here. Now the low voltage capacitor holds 100,000 RF. You can see that in the Waylo tooltip. The medium voltage capacitor holds 1 million RF. And if we hook these up, you can see that power not going through, and that would likely be because this is configured as an input when it needs to be an output. So if I tap it with the hammer, all of a sudden the power is going. And if I right click here, you can see we have 1020 RF per tick, slight energy loss. If we use the voltmeter, shift right click, 0.1, I don't think that took. Shift right click, shift right, that did not work. Okay, there we go. Now you can see that the average loss is 0.625%. Now that is exactly half of the energy loss of the low voltage capacitor. Now if we do the same thing with our high voltage capacitors and I configure this to be an output, see the power's going. We got 4089 RF per tick. Use the voltmeter, shift. Why is that not? Now you can see that we have 0.312%, which is exactly half of 0.625%. So each tier you go up, the energy loss is down by half. So that's pretty convenient. You want to make sure that you're transmitting high voltage over long distances. If you're transmitting low voltage over long distances, you want to figure out how to do that on a high voltage wire and not use this low voltage wire. Otherwise, you're going to lose quite a bit of power. All right, so that being said, before I show you all this mess down here with the wooden posts, let's take a look at how we configure the wooden post. So if I have a wooden post here, you set it down, it's got no arms. If I then use the engineer's hammer and tap aside, now you see I've got an arm out. If I do it on the other side, now I have two. Now I can do this in any orientation I want. I can do it this way as well. Unfortunately, I can't do the other sides. Once you pick an orientation, you can only do it on opposing sides. Now, let's see. I need some connectors. Put some connectors up here. You can put connectors on all 3 points. If you then put a block below here, you can also add 2 more underneath for a total of 5. Pretty cool. Looks like a real world power line. So that's pretty cool. So let's talk about how we connect all these up and some of the challenges with converting between different tiers of power and wire. So I've got 3 of these creative capacitors here, and the only reason I'm doing this is each of these connectors represents a machine on the network. So I've got here 3, 6, 9, I've got 10 machines hooked up to the power grid providing power, and you can see I can hook all these wires up into one connector, and that's totally legal. Now, one thing interesting to note here is that according to the engineer's manual, if you overload a wire, it'll burn up. Now, I intentionally put 10 wires on here. This wire is supposed to hold up to 8 of these connectors. 8 at 256 RF per tick will equal the 2048 RF per tick that this thing supports. But as you can see, I've got 10 hooked up here, and this wire is not burning up. If we come down here and actually complete the circuit, you can see that power is transmitting just fine. Wire's not burning up. All that it does is limit the power throughput. So if I look at this, I've got about 267 RF per tick going through the current transformer. All right. So let's look at, actually, instead of letting that roll, I'll show you how to use these wire cutters. You can forego the wire cutters and just break the connector, but if you use the wire cutter and just right click, it pops the wire off and you don't have to replace the connector. So that's the wire cutters. Alright, so I'm going to turn this rain off. Alright, so let's look at how we take power from one tier and connect it to a higher tier. So right here I have a wooden post with a low voltage wire connector and several machines hooked up to the network. So we're transmitting power on a low voltage line to this pole, and what I've put on this pole is a transformer. Now there are 2 tiers of transformer. You've got a regular transformer and a high voltage transformer. The regular transformer handles low voltage to medium voltage conversion, and then that's what you see here. Now the regular transformer you can mount on a pole like you see here, which is kind of cool, or you can use it standalone, which is the block that you see here. So this only handles low voltage to medium voltage. So you connect the low voltage wire to the top, you connect the medium voltage to the one on the side, and now you have consolidated all that power into a medium voltage power wire or a medium voltage wire. And here you can see now we've got several machines with medium voltage wire connectors hooked up to the same connector and transmitting power here. So if I then connect this, oops, you can see we're powering up over here. So we've successfully converted or connected low voltage to a medium voltage power grid. Now you can do the same thing with the high voltage wire, the high voltage transformer. This one you cannot mount on a post. But what you can do is, in this example, I've got several medium voltage connections hooked up to one connector and hooked up to the transformer, which we're then transforming into high voltage. You can also take low voltage connectors and connect it, but you can only do one wire. You have to do either medium voltage or low voltage, but either one will work. So you can see now we're taking the high voltage, connecting it to this HV wire relay. Now I've got a bunch of high voltage machines here connected to it, and now connect a circuit here, and we've got power rolling. You can see we've got 4200 RF per tick rolling there, 1077 RF per tick there. All right, so that's that. Now on the HV wire relays, you can see here I've got multiple high voltage wires connected to it. This wire relay can only transmit power. You can't take this and put it, for example, on a capacitor here to input or output power, because it won't do anything except transmit it. Likewise, you cannot take this HV wire connector and mount it on this post and expect more than one wire to connect to it, because it will only take one wire. So that's the main difference between an HV wire relay, or sorry, an HV wire connector and the other two tiers of connector. All right, so enough of that. Let's look really quickly at wire ranges. How far can you string these wires up? So if you look here, I've got a wooden post with a low voltage, medium voltage, and a high voltage wire relay all in the same post. The medium and low voltage wires can run up to 16 blocks. That's what we have here. You try to go past that, it'll just tell you can't connect the two because it's too far. But on the high voltage wires, these can go 32 blocks, quite a ways. But you can see on the standard wooden post here, it looks very weird because it almost drags the ground. So you'll notice on the side here, I've got some much taller poles. And this is an interesting, I do have them here. So this isn't actually part of Immersive Engineering. It's part of an add-on called Immersive Integration, but I thought I would demo it here simply because that looks so much better than the wire hanging on the ground. So to use this extendable wooden post, you just put the post in the ground, and then you take treated wood fence and just stack those as high as you want. You can go way up in the sky if you like. And then just like the other ones, the other wooden post, use your hammer to put arms on it, and away you go. So that's the lowdown on how far these wires go. Now, the last two things I have to show you for wire or for power transmission are the breaker switch right here and the Redstone Breaker. Now these two things are pretty much the inverse of each other. So the breaker switch is constructed with 2 hardened clay, copper ingot, and a lever. And the Redstone Breaker is constructed of 2 high voltage wire connectors, a redstone repeater, 4 iron ingots, and a piece of redstone. So I've got these set up over here to kind of demo it. This is a redstone switch, or I'm sorry, this is a breaker switch. Now you can see right now it's in the off position. The circuit's broken, but when you click it, it completes the circuit and now power is generating. If I turn it off, it stops the power. And it's important to note too, when it's on, it transmits a redstone signal, and when it's off, it stops. So that can be handy, depending on how handy you are with redstone. Now the Redstone Breaker operates a little bit differently. It's on by default, and when you want to break the circuit, then you provide a redstone signal and it will break the circuit. So right now the circuit's broken, there's no power transmitting. You can see there's a redstone signal being supplied here. When I turn that redstone signal off, the power turns on. So it's exactly the inverse functionality of the breaker switch. Alright, so that is all I've got for power transmission and storage with Immersive Engineering. I hope you found this useful. If you did, please leave a like. If you didn't, feel free to tell me why. We can always improve. Until next time, go forth and be awesome.